Okay, good afternoon again, and thank you everyone for attending today's webinar, Are You at Risk? The Role of Lockout-tagout in Pneumatic Safety, brought to you by Bimba Manufacturing Company and Design World Magazine. I'm Leslie Langnaw, Managing Editor for Design World Magazine, and for those of you who are new to the Design World offerings in hydraulics and pneumatics, you might want to visit Mobile Hydraulic Tips and Pneumatic Tips, which are great online resources. Now, I would like to take this opportunity to thank our presenter for being here today and to introduce him. Jerry Scherzinger is Product Manager for Bimba Manufacturing Company. Jerry has 18 years of experience with Bimba Manufacturing and more than 20 years in the fluid power industry. He holds a Bachelor of Science in Physics from Illinois State University, and he is certified by the Fluid Power Certification Board as a Certified Fluid Power Pneumatic Specialist and has been since 2006. Before Jerry gets started, though, just a couple of housekeeping details. If you wish to tweet about this webinar anytime during or after, you can use the hashtag DWWebinar, all one word, and we will have a Q&A session after the presentations. But you can go ahead and submit your questions as you think of them, and we will ask as many of them as we can after Jerry is finished. So go ahead and ask your questions in the dialog box on your screen. And at the moment, now we're going to go to our presentation, and Jerry, the mic is now yours.
Thanks, Leslie. Excuse me. I'd like to start off by let's take a quick look at our agenda and what will be covered in today's webinar. And then following our introduction, we'll take a look at some existing OSHA and ANSI standards that are applicable specifically to pneumatic safety. The best practices, then we'll get into best practices for safely maintaining industrial machinery. This is primarily general information, not as much pneumatic specific. Following that, we'll talk about lockout-tagout and the use of pneumatic isolation valves. And this will highlight the importance of lockout-tagout and provide a component-specific example of how proper lockout-tagout can improve worker safety. After that, we'll take a look at the actual PIV, or pneumatic isolation valves. This will be a little bit deeper dive into pneumatic isolation valves themselves and how they are used. And then finally, kind of our call to action for everyone. And we would suggest that everybody responsible for worker safety within their facilities should conduct the audit that we will give at the end of this presentation. And I'm challenged to advance the slides, guys. Have you made me the presenter? There we go. So, as an introduction, a primary cause in many industrial accidents is that equipment that is under repair starts or moves suddenly while the worker is still in a dangerous position within the machine. This can happen when there's a failure to properly identify, isolate, and eliminate stored energy sources within the equipment prior to beginning maintenance tasks. This stored energy, which is often referred to as potential energy, can be very dangerous if it's not dissipated because it can cause unexpected machine movements, and even when the machine is turned off. Residual pressure in hydraulic or pneumatic lines, stored electrical energy, and stored pressure in compressor tanks or accumulators are examples of these potentially hazardous energies. Proper maintenance protocol should include the dissipation of hazardous energy prior to any maintenance personnel working on the equipment. Over the past 10 years, an average of 5,433 U.S. workers have died in fatal work injuries. And it should be noted that overall injuries and fatalities are declining, but that's still a pretty significant number. And it's fairly easy to identify a lot of the hazards that you see in the workplace. You know, we all know not to walk under a loaded crane or not to reach around machine guards, but potential energy sources are often invisible, making them that much more dangerous. Primary oversight of safety in the workplace in the United States resides with the Occupational Safety and Health Administration, or OSHA, as we refer to them. Each year, OSHA publishes data on the standards that are most often violated and lead to injuries, as well as a list of the highest OSHA-assessed penalties for workplace safety violations. In 2011, the improper control of hazardous energy, or lockout-tagout, those standards ranked 5th in the list of the most frequent violations and third in the list of the highest penalties assessed to employers for violating these standards. So with those top 5 rankings in each of their 2 categories, you can really see the importance of a good understanding of this topic and how it applies in your facility. Could you advance the slide for me again? For whatever reason, I'm having a hard time here picking this up, so I'm going to give you a notice as to when to do that. Here we can see 3 safety standards that apply to pneumatic safety. The first one, ANSI B11.0, Safety of Machinery, General Safety Requirements, and Risk Assessment, is fairly general in nature. The chart on the right is taken from the B11.0 safety standard, and it shows a process flow for conducting a risk assessment. The key to this risk assessment process is defining residual risks and acceptable risks within the overall strategy. And it can best be defined as a repetitive process with the goal of reducing all the identified risks to the acceptable level. So you identify the risks, and then as you go through that flow chart, your repetitive process hopefully reduces them all to an acceptable level. And I should point out that throughout this presentation, I'll use a number of different abbreviations. ANSI is the American National Standards Institute, and PMMI, which I'll also refer to, is an acronym for the Packaging Machinery Manufacturers Institute. Number 2 on this slide, the ANSI PMMI B155.1 actually specifically relates to pneumatic safety, and it's within this standard that we see a direct reference to the need for an energy isolation device. Now, making reference, as Leslie mentioned, you'll all get a copy of a white paper as well after this presentation, and within that white paper, there's some specific notes as to what's covered under this ANSI PMMI B155.1, and they refer to safety shutoff and exhaust valves. An energy isolating device can be provided to shut off and release pressure from the various systems and shall, and then they go into 4 individual bullet points that you'll see in the white paper. And those criteria are they should be capable of being locked in the off position only. They can only be locked in the off position. They should be easy to operate, for example, a simple push-pull action for pneumatics. They shall have a properly sized exhaust port to exhaust pressure in an acceptable period of time as determined by the risk assessment. And they shall have a pressure indicator that is visible to the operator to indicate that the line is relieved of pressure. Number 3, the Control of Hazardous Energy Lockout-tagout is an OSHA standard, and this explains that proper lockout-tagout requires that a designated individual turn off and disconnect machinery and equipment from its energy source before performing that service or maintenance. Please advance the slide. Maintenance is essential in any industrial setting for the equipment to operate in a safe and efficient manner. Maintenance can be a costly element of facility operations in terms of budget and impact on operations. Maintenance can also be a potential workplace safety issue if it's not properly addressed. There are 3 common types of maintenance that are carried out in every facility. Emergency repairs when something breaks, and this is an unavoidable type of a maintenance. It's not scheduled. Then there's preventive maintenance, which is carried out on a piece of equipment at a certain time interval. And then I would consider this to be a planned type of maintenance. And then number 3, predictive maintenance, which is carried out when tests indicate that maintenance is needed. Please advance the slide. Regardless of the type of maintenance, a number of important activities must take place if the maintenance is to be carried out in a safe manner. The equipment selected to have maintenance carried out must be isolated. This includes ensuring that all sources of energy to the equipment are inaccessible and disconnected and tagged off. The power source should also be tagged off or off under repair with the date and signature of a person authorizing the procedure. This is done so that someone does not turn the power on until the work is completed. The equipment must also be isolated from other equipment in the same system. it's very important to recognize that simply turning the equipment off is insufficient protection for maintenance workers. Everyone should take care. Care must be taken to further identify potential energy sources at their point of use and to release any potential stored energy in the machine subsystems. An example would be the use of a pneumatic isolation valve capable of exhausting stored pneumatic pressure or energy, for which it is possible to lock and tag in the off position. And we'll talk a little bit more about that in subsequent slides. Maintenance procedures must be developed for all equipment. These procedures should follow the manufacturer's recommendations and include all instructions, drawings, and lists of parts. Maintenance activities, even emergency repairs, must be planned. The time it takes to plan a job, read the maintenance procedures, and get the needed safety equipment will more than be made up in the safety of the job and the ease in completing the job. A little planning in this area goes a long way in doing and providing safe maintenance. To rush into an emergency repair really is to invite disaster. Maintenance personnel must be trained on the equipment. The proper equipment must be used to safely carry out maintenance. Proper safety equipment such as gloves, eye protection, foot protection, and hard hats should always be used. Any safety devices or shields removed during maintenance must be installed on the equipment prior to the completion of maintenance. Any shields and safety devices originally installed on a piece of equipment must not be left off, quote unquote, to make it easier to fix the next time. So make sure we put all the safety guards back on. Prior to returning the equipment to service, a supervisor who is familiar with the equipment and the maintenance should check the equipment to ensure that the maintenance is complete. The equipment is properly reassembled. All safety equipment and any tools used in the maintenance have been removed. Please advance the slide. Let's take a little closer look at pneumatic isolation valves and their contribution to pneumatic safety and lockout-tagout procedures. Pneumatic isolation valves are typically the first valve in the system, following the FRL, the filter regulator components, and the line supplying compressed air to the pneumatic equipment. So you can see that in the graphic on the screen. However, it should be noted that some applications successfully place the PIV, or the pneumatic isolation valve, before the FRL to facilitate maintenance of the FRL components. The concern with doing this is that when you actually when you actuate the isolation valve, you get a rush of backflow exhaust back through the regulator. So customers need to be sure, if they're going to install the PIV valve before the FRL, you need to be sure that your regulator component in your FRL can handle that backflow through the regulator without damaging the diaphragm. Next slide, please. Let's take a little closer look at how the actual pneumatic isolation valves work. Recall that ANSI B11-2010 states that an energy isolating device shall be provided to shut off and release pressure from the various systems. And again, with many of the ANSI standards, there's 4 or 5 criteria that are associated with each standard. In this case, B11-2010 section 7.11 specifies that they should be located outside of the hazardous area, be capable of being locked in the off position only, be easy to operate, have a properly sized exhaust port equal to or greater than its supply port, and then this one's critical. We'll talk a little bit more about this one as we go on. And have a pressure indicator, for example, a gauge, that is visible to the operator to indicate that all pressure has been relieved. Now, in the image on your screen, in the upper right-hand corner of the yellow PIV valve, that's what there we're showing a pressure switch. So there's 2 ways of doing that pressure indication. Electrically, we can have a pressure switch send a signal to a PLC or other device, or, excuse me, it can be done mechanically through the use of a pop-up indicator. And the easiest way to picture a pop-up indicator is, for those of you that have made a turkey on Thanksgiving, for example, when the turkey's done, you get a little red ball that pops up to indicate the turkey's done. very similar to that. It's a red visual flag that is popped out of that valve when pressure is still maintained at the PIB valve. Please advance the slide. Here's a number of cutaways that can help us understand how the pneumatic isolation valves work. So on the first slide on the left, you can see that when the handle is pushed inward and supply air is blocked, downstream air is exhausted via the exhaust port at the bottom of the valve. So the blue path there is the air coming back from the equipment, exhausting through the valve, and the red is supply pressure that's blocked from entering the system. The PIB valve should be locked in this position to prevent the handle from being pulled outwardly, inadvertently, where potential for human injury exists. So that's really the lockout-tagout portion of what we're talking about here with pneumatic isolation valves. Once it's actuated, proper maintenance protocol is to engage the lockout-tagout. Typically, there will be an area for the maintenance person to sign that tag, and they will have an individual lock and key that they can use. And because only they have the key, that will remain engaged until the maintenance worker removes that lock from the device, indicating that it's safe to operate the equipment. To the right of the screen, when the handle is pulled out, supply air is now allowed to flow freely from the inlet to the outlet, and flow to the exhaust is blocked. A detent keeps the handle in the open position. The handle is not designed to be locked in this position. Thereby, it provides for ready shutoff whenever it's necessary. And again, making reference to the white paper that you'll all receive, you can reference that white paper for a number of examples of devices that are not OSHA and ANSI approved. And this is very important because I see this in a lot of facilities as I travel, and it's very common to use devices that, should you have a situation where OSHA's got to come into your facility, in the unfortunate case of an accident, if you're using something that's not OSHA or ANSI approved, that's where you really open yourself up for fines and citations from OSHA. Some examples of what devices are used that are not OSHA and ANSI approved. First example would be a ball valve, and it's not allowed by their standards to use a ball valve as a means of isolation. They're not an approved method. There's a number of reasons for that, some of which we've covered. Ball valve shutoffs, are not positive. So it's not an on-off device. It's an infinitely adjustable valve that can be partially open or partially shut, not fully open or fully closed. Ball valves do not have a full exhaust port. And recall that in the PMMI spec B155, the need for a full exhaust port exists. Part of the reason, or a main reason for this, is when the isolation valve is energized, recall that some of the other criteria that we discussed were a full-sized exhaust port. So when you're isolating your energy for maintenance, it's very important that the pent-up potential energy is exhausted quickly to allow the maintenance worker to get into the equipment. This also has a financial component associated with it. Excuse me. Because you want to minimize the time that machines are down for maintenance. So if you use a ball valve that typically has orifices as small as a 1/16 of an inch, the time it takes to exhaust all that machine air outside the orifice when it's only a 1/16 of an inch can be many, many times greater than provided by a PIB valve, which has a full-sized, or actually, in many cases, an oversized exhaust port. And there's also an inability to install a muffler on a ball valve, which presents a safety concern in that there's a concentrated exhaust path through that ball valve. So as the air comes rushing out the ball valve, because it's a small orifice, instead of being dissipated into a large area, it comes out of an orifice as small as a 1/16 of an inch, and it can create eye hazards. Other examples of shutoff valves that are commonly used but do not meet OSHA and ANSI standards would be a slide-type valve, so just a simple gate valve that's used very commonly for on-off. While many of these can be locked, they do not meet these standards because they do not have a full-size exhaust port. Another example would be a rotary-style shutoff valve. These, similar to ball valves, can be locked in the partially on position, and it's not a simple push-pull device. So these are the types of things that in the unfortunate event that you do get an OSHA audit, these are the things they'll be looking for to ensure that you are taking all the steps that you can to provide a safe work environment for your workers. Please advance the slide. So the following 3 slides will represent what I call our call to action for everyone attending this webinar. And we recommend that you audit your current safety and lockout-tagout procedures using these criteria, and these will also be included in the white paper that you receive. And the question you need to answer is, can you answer yes to all of these questions? And if you're unable to answer yes, then you need to make some changes within your facilities to be sure that you fully comply with proper lockout-tagout procedures as specified by OSHA. Please advance the slide. Is all of your machinery or equipment required to be de-energized or disengaged and locked out during cleaning, servicing, adjusting, or setting up operations? Is it prohibited to lock out control circuits in lieu of locking out the main power disconnects? So now we're getting more into the electrical side of some of these requirements. Ask yourself, are all equipment control valve handles provided with the means of lockout? Does the lockout-tagout procedure require that stored energies in the form of mechanical, hydraulic, or air be released or blocked before equipment is locked out for repairs? Are appropriate employees provided with individually keyed personal safety locks? So each maintenance worker should have their own set of lock and key that they use. It's very common to have a workstation within the maintenance area where commonly used lockout clasps are stored, and that's the device which many times actually goes in and engages the equipment. But it's very important that each maintenance worker have his own individual lock and key. Also an area that OSHA will look at in the unfortunate event of an accident. Please advance the slide. Are your employees required to keep personal control of their keys while they have their safety locks in use? Is it required that employees check the safety of the lockout by attempting to start up the equipment after making sure no one is exposed? It's important that they understand where the power disconnecting means for equipment does not also disconnect the electrical control circuit. Are the appropriate electrical enclosures identified? And are there proper means to ensure the control circuit can also be disconnected and locked out? So there's a number of things to bring back to your facilities as part of your audit. It's very important that you're able to answer yes to all those questions. That will provide you the protection not only from fines from OSHA, but more importantly, it'll give you a comfort level that you're providing a safe work environment for all of your workers. So this will complete the presentation portion of today's webinar. Leslie, were you able to identify any questions during the presentation?
Yes, a couple did come in. So the first question that we're going to ask is, somebody mentioned that your presentation implies that it's best to locate the PIV valve downstream of the FRL in the pneumatic circuit. And you did talk a little bit about putting it prior to that. Do you want to go into that a little bit more deeply?
Yeah, actually, we've seen customers do it both ways. They can either put it before or after the FRL. I've even seen some customers that will install a PIV valve in both locations, both before and after. The nice thing about doing it before the FRL is it does allow you to isolate the FRL itself for maintenance. So if you wanted to shut off the PIV and it was located before the valve, you can engage the PIV and exhaust all the air back through it, and now you're able to work on the FRL components without them being under pressure. But as I mentioned, typically it's best to have it be the first valve in the system, because you don't have the concern then about backflow of pressure back through the FRL. There's many regulators on the market that are capable of handling this backflow, but it's our recommendation that because every customer doesn't understand what type of regulator they've got in their equipment, if it was a turnkey operation, for example, they didn't specify the FRL. So in an interest of protecting that component, that's probably the best way of providing that installation.
A couple of housekeeping questions have come in. As Jerry has mentioned, there is a white paper that will be sent to everyone who registered for this webinar. Another question that came in was about a certificate of attendance, and I'm not sure, I don't know if you could answer this, Jerry. I don't know that this webinar is considered continuing education or anything like that.
To my knowledge, it is not. We've not sought out anything like that, so I would say it is not.
Okay. Another question, this person is asking again about the ball valves, the slide gate valves, and rotary shutoff valves, that they're not considered OSHA ANSI approved, and his question is, why is that?
There's actually a number of reasons. Probably the primary reason is that ball valves, by the nature of their design, they can be adjusted in, I'd say, infinite positions between fully on and fully closed. The requirements from OSHA and ANSI are that this is an exacting off or on style valve. So it's either got to be fully opened or fully closed. And that's not the case with a ball valve. A ball valve, for example, can be positioned 25% open, 50% open. It's really intended to be more of a metering type valve and not so much of an on-off valve. That's the primary reason. The secondary reason that also does not match with some of the OSHA and ANSI requirements is a ball valve's got a very small exhaust port. So it takes a good deal of time for all the pent-up energy in the form of air pressure to be exhausted through that valve, whereas a PIV, or a pneumatic isolation valve, has an oversized exhaust which virtually immediately exhausts all the air. So the danger there exists that if a ball valve is used, a customer could shut that ball valve off thinking that it's now safe to work on the equipment, when in reality that pressure is still bleeding off through the very small orifice. So, if the device is such that a load is suspended, for example, the customer or the maintenance worker shuts it off, he thinks it's safe, he goes under the suspended load, and as the pressure bleeds off, the load falls or something like that. So there's a number of reasons why ball valves are not really acceptable per OSHA and per ANSI.
Okay, another question has come in. How can you adjust cylinder switches and other similar devices with the air off? Sometimes the air must be on, and is this allowed?
Certainly cylinder switches can be adjusted with the air off by doing it in a manual operation. We frequently see customers manually position either their end devices or the cylinder rods to position the switches. That's with regard to air pressure. Obviously, electrical energy has to be present for those switches to be positioned. As it applies to good maintenance procedures, that's a little bit outside the scope of what PIV valves are used for. So in that case, you're getting more into the electrical side of things and presets, and it's impossible to do it with the electrical energy off. So I don't know that that's necessarily a maintenance issue as much as it is kind of a preset issue or a setup type of a question. And
Okay.
I don't know that entirely answers the question.
Okay, and just a reminder to everyone, please go ahead and enter your questions onto the portion that you'll see by your slide. And you can also phone Bimba. You can email Jerry if you have questions that you would prefer to ask offline. But this was a very informative webinar about lockout-tagout information, because that's quite a key area for the industry to stay on top of. Another question just came in. Companies manufacture OSHA-approved lockout-tagout devices for ball valves and gate valves. Do you want to make a comment on that?
I'm trying to look at the wording of that. Companies manufacture OSHA-approved lockout devices for lockout of ball valves and gate valves. So I think what the questioner is asking is it safe or approved to add an additional device to the ball valve or the gate valve? And if I'm understanding that right, yes, that's possible, but now you're looking at two components, and that's something that people would do to make a ball valve or a gate valve OSHA approved. The message I was trying to send is, without the presence of those additional devices, which is the most common thing that I see in industry, they're not safe by themselves, and they're not approved by themselves. So, one of the other advantages to a pneumatic isolation valve over a ball valve is, if it is a situation where you need to quickly shut off power, I know myself and then probably many of the people on the call have been around equipment that has 5, 10, 20 different ball valves located in a ganged valve area, and they all look the same. So the advantage to a device like a pneumatic isolation valve is it's big, it's safety yellow, and it's very easy to identify, whereas it's a bit of a dicey situation if you've got to locate the one ball valve to shut off the air supply in an area where potentially there's a large number of ball valves kind of ganged together.
And you need to move quickly in some cases.
Exactly.
Mm-hmm. Okay. Any other questions that anyone would like to ask? We'll hang out for a few more minutes for some more questions that might come in. We have a couple of comments from people that have said that this has been a very informative webinar. So
appreciate that.
Yeah, and just as a reminder, you will all be getting a copy of this in the next day or so.
And I want to point out this, we allocated an hour for this presentation. I realize it took approximately a half an hour. I hope anybody doesn't feel slighted by that. It's been my experience that to take up so much time sometimes is not a positive thing. So I tried to limit some of the information actually presented in the live webinar with the idea that the white paper that will supplement this webinar will contain additional detail.
Do you want to go back over that question about companies that make OSHA-approved lockout devices for ball valves and gate valves? One of the attendees, I think, would like a little more clarification on that.
Okay. Yeah. So the message in my webinar was that by themselves, a ball valve or a gate valve are not OSHA and ANSI approved. And what we talked about was the fact, I think the questioner is asking, are there devices out that companies make to allow a ball valve or to allow a gate valve to become OSHA or ANSI approved? And honestly, I'm not personally familiar with those devices. But the message here was that by itself, a ball or a gate valve is not approved. And the reasons we talked about, the ball valve being able to be located or adjusted in interim positions, whereas OSHA requires an on-off, a definite on-off type of a mechanism for a safety valve, whereas a ball valve can be adjusted, for example, in the partially open or partially closed position. One of the other requirements through PMMI is that these safety valves have to have an exhaust port at least equal to or greater than the size of the supply port to allow for quick exhausting of the pent-up energy. A ball valve does not do that. It's got a very small orifice, as small as a 1/16 of an inch. And a gate valve has the same situation, where it does not have an oversized exhaust port. Excuse me. So with regard to devices that allow ball or gate valves to become OSHA and ANSI approved. I think everybody's got a little bit of homework to do, myself included, as to how it would allow for a ball valve to become approved unless they do something on the exhaust side. And honestly, I'm not aware of how they would do that, but that's not to say it doesn't exist.
Okay. Go ahead, Jerry.
I was just going to say, but short of adding additional components to your ball or gate valve, a pneumatic isolation valve would be the way to go. Certainly there's a little bit more cost associated with it, but in the areas of safety and worker safety, the penalty and the cost of not doing it far outweighs the initial installation price of doing it. So when you look at it from a risk-reward type of an analysis, I think it's money well spent.
Mm-hmm. Yeah, agreed. Okay, so if there are no more questions, just be aware that you are free to email Jerry or myself, and the information is on that screen. And we will direct the emails and questions appropriately. Thank you, everyone, for attending this webinar from Design World and Bimba Manufacturing Company. As I mentioned before, this presentation will be emailed to everyone in the next coming days, along with Jerry's white paper. And the presentation will also be available at www.designworldonline.com. So thank you again for attending, and have a great rest of your day. Bye-bye now.